Ladies and gentlemen, welcome. Something that was previously inconceivable is now commonplace. You get in your car, type your destination into your satellite navigation system, it starts to plan your route, and off you go. You put your faith into your sat-nav and just look forward to getting to where you want to go. But what if you were to suddenly find yourself arriving somewhere completely different? Maybe you think that your sat-nav had made a mistake or that you put in the wrong address. Yet, what if you had done everything right and someone had manipulated the GPS data on your device? These days, it's perfectly possible. Anyone can manipulate GPS data using simple tools. They're what's known as GPS spoofing attacks. Just imagine what an impact a spoofing attack could have on these types of transport or aircraft. As you can well imagine, such an attack on a craft like this would be fatal. These crafts are completely dependent on correct GPS data for their navigation. And there's the problem. GPS is susceptible to manipulation. And using a transmitter to send fake signals from the ground is child's play. Mr. Lenders is now going to run an experiment to show us exactly how a GPS spoofing attack works.
So in this experiment, I will demonstrate how GPS spoofing attacks affect standard GPS receivers. I have here a setup with a software-defined radio and a computer, which I'll be using to generate fake GPS signals. I will now start a script which generates those signals. And here on the table, I have an iPad with a software, an air navigation software that is used by pilots, and displays the location of the aircraft. So this is just to demonstrate that with this very simple setup, which costs just a few €100 and that you can buy online, you are able to launch GPS spoofing attacks that cannot be detected with the classical GPS receivers.
Thank you very much, Mr. Lenders. Now that we have seen how easy it is to manipulate GPS signals, it raises the question of how we should assess this threat and whether incidents like this have already happened in the past. Ms. Pepper can tell us more.
In 2017 and 18, two GPS spoofing incidents were reported on the Mediterranean Sea and on the Black Sea. Several vessels claimed being up to 40 kilometers off course at an airport rather than at the harbor where they actually were. It's also widely believed that back in 2011, a US Sentinel drone that had crash-landed in Iran was tricked into believing it was at its home base.
Thank you very much, Ms. Pepper. As you can see, the threats and their potential consequences have to be taken very seriously indeed. Our team has recognized the risk and worked hard to find a solution. How does this solution work, Mr. Lenders?
We have developed a solution to detect and localize GPS spoofing attacks, which we call CrowdGPSSec. And the core idea is to rely on existing wireless signals that aircraft continuously transmit for air traffic control purposes. So when a spoofer is active, it will transmit signals, and the aircraft in vicinity will lock to the signals of the spoofer and start transmitting false position advertisements. So by leveraging an infrastructure of ground receivers, we monitor all the data that the aircraft transmit, and we check if the data is correct or not. So with CrowdGPSSec, we are able to detect GPS spoofing attacks in less than 2 seconds. And we are also able to localize the attacker after 15 minutes monitoring time.
How can global coverage be guaranteed and how can it be financed?
Well, the nice thing about CrowdGPSSec is that we don't need an update of the infrastructure. So there is no need to update the GPS receivers or the satellite infrastructure. In this work, we rely on the OpenSky network, which is a crowdsourcing initiative to collect air traffic control data. Everybody is an open initiative where everybody can participate. You can plug in your own sensor to the network. And if you cannot afford for one, you can apply for a free one through crowdfunding. So with this approach, we have already very high worldwide coverage.
Thank you, Mr. Lenders.
You're welcome.
And thank you too, ladies and gentlemen, for your interest and your attention on how GPS spoofing attacks work and how they can be successfully detected in the future.